All right, algebra. So continuing on with quadratic equations, and today talking about completing the square. So sometimes we have quadratic equations like a squared plus 6a plus 2 is equal to 0 that cannot be solved by factoring. In this case, this particular quadratic equation, we would not be able to solve by isolating the square either. So what do we do? Um, if we added 7 to both sides of that equation, therefore keeping it balanced and keeping it equal or equivalent to its original, we would end up with a perfect square trinomial that could be factored. So here's our original, a squared plus 6a plus 2 is equal to 0. If we add 7 to both sides, we get a squared plus 6a plus 9 is equal to 7. And then we can factor a squared plus 6a plus 9, because that's a perfect square trinomial. It ends up being a plus 3 squared is equal to 7. We could solve this by taking the square root of both sides. We would end up with a plus 3 is equal to plus or minus the square root of 7. And then we would subtract 3 from both sides, and we would end up with a solution of a is equal to, we would subtract 3 from both sides, plus or minus square root of 7. So we could solve it that way, okay? So that is what we're going to be doing. That, in essence, is what's called completing the square. Looking for an addend that we can add to both sides of a quadratic equation that will give us something that we can then solve for, thus completing the square. How do you decide, or how do you determine what to add, though? Okay, you do that by taking C right here and moving it over to the other side, okay? That gives you a squared plus 6a is equal to negative 2. And what we're most concerned about at this point when we're talking about completing the square is what's left right here. And we are going to call this the form x squared plus bx. And when we are completing the square, when we're trying to complete the square of an expression in this form, we add the square of half of the coefficient of x, okay? So here is the coefficient of x. So what we do is we say x squared plus bx plus b over 2 squared, okay? So what we're going to do to determine what to add is we're going to take b, divide it by 2, and square it. And that is what we are going to add to complete the square. So example number 1 just says complete the square and factor. Okay, so we have x squared minus 16x. So first identify what is b. In this case, b is right here, and b is equal to negative 16. So remember, we're going to take b over 2 squared, okay? So negative 16 over 2 squared, okay, is equal to negative 8 squared is equal to 64. Now we take x squared minus 16x and we add 64, okay? Factor this resulting trinomial. This is a perfect square trinomial, which factors to x minus 8 squared, okay? B is x squared plus 3/5 x. Identify what is b. There's b right there. So remember, again, b over 2 squared, okay? So 3/5 divided by 2. Remember, b over 2 is the same as b times 1/2, right? So if b is 3/5, that means we're taking 1/2 times 3/5 squared. So that is 3 over 10 squared, which is 9 over 100, okay? Take your original x squared plus 3/5 x x. Now add 9 over 100 to complete the square. Factor that out, okay? And that is x plus 3/10 squared, okay? You can use this method to solve any quadratic equation in the form x squared plus bx plus c is equal to 0. Remember, if you add a number to one side of an equation, you have to add that same number to the other side to keep it balanced. So example number 2 is x squared plus 8x is equal to 9. The first thing we need to do is we need to complete the square. What is b? B is 8. So to complete this square, we're going to add 8 over 2. So that's b over 2 squared. So 8 over 2 is 4. 4 squared is 16. So now we have x squared plus 8x plus 16. If I add 16 to the left side, I need to also add 16 to the right side of the equation. Okay? Now, factor this perfect square trinomial, x squared plus 8x plus 16. That is x plus 4 squared is equal to, now that's equal to 25. It's not equal to 0. Okay? So now I need to solve this using the square root property. Take the square root of both sides. I get x plus 4 is equal to plus or minus 5. Subtract 4 from both sides, and x is equal to 5 minus 4, which is 1, or x is equal to negative 5 minus 4, which is negative 9. So my solution set for x is 1, negative 9. Okay. Here's the steps that we just worked through, okay? Number 1, write the equation in the form x squared plus bx is equal to c. Complete the square by adding b over 2 squared to both sides of the equation. Factor the resulting perfect square trinomial. Apply the square root property. If x squared is equal to n, then x is equal to plus or minus square root of n, and solve. So example number 3, solve a squared minus 7a minus 3 is equal to 0. Our first step in this case is to write the equation in this form, which means I have to add 3 to both sides. That gives me a squared minus 7a is equal to 3. What's b? B is negative 7. Negative 7 over 2 squared. Okay, negative 7 over 2 squared is 49 over 4. So I have a squared minus 7a plus 49 over 4 to complete the square on the left is equal to 3, and I have to add 49 over 4 to the right-hand side to keep my equation balanced, okay? 3 as a fraction with 4 in the denominator is 12 over 4, okay? Now, factor the resulting perfect square trinomial on the left. That is a minus 7 over 2 squared is equal to 12 over 4 plus 49 over 4, which is 61 over 4. Take the square root of both sides. That gives me a minus 7 over 2 is equal to plus or minus the square root of 61 over 2. Where did that come from? Square root of 61 over 4 is equal to the square root of 61 over the square root of 4, which is the square root of 61 over 2. Okay, so a minus 7 halves is equal to plus or minus the square root of 61 over 2. Add 7 over 2 to both sides. A is equal to, those have the same denominator, so 7 plus or minus the square root of 61 over 2. That is the answer, okay? If you were asked to give a decimal approximation of this, you would do 7 minus the square root of 61 divided by 2 and the square root, or excuse me, and 7 plus the square root of 61 over 2. Okay, that would give you negative 0.41 and 7.41. Decimal approximations, radical answers. Okay, all right. Example number 3 illustrates that the sign of b can be ignored when b over 2 is squared. Leaving the expression as b over 2 squared may make the factoring of the perfect square trinomial easier. Let's look at a story problem. Cassia increased the area of her garden to 550 feet squared by adding 4 feet of width, that's right here, and 7 feet in length, right here, to the original garden. So the original garden is what's in yellow. Find the original dimensions of her garden, okay? So x is equal to the original length and width of her original garden. Original. Okay, x is equal to the length and width, okay? The new garden is x plus 4 is the width, and the length of the new garden is x plus 7, okay? Now, area is equal to length times width. We know the area of her new garden is 550, okay? So, x plus 4 times x plus 7, there's the width of the new garden, there's the length of the new garden, is equal to 550, okay? Foil this, you get x squared plus 4x plus 7x plus 28 is equal to 550. So x squared plus 11x plus 28 is equal to 550. Now we're going to complete the square. In order to complete the square, I need to put this into the form x squared plus bx. So first thing I have to do is subtract 28 from both sides. That gives me x squared plus 11x is equal to 522. Now, what is b? B is 11. So b over 2 is 11 over 2 squared. Okay, 11 over 2 squared. So we're just going to leave that like that for now. X squared plus 11x plus 11 over 2 squared is equal to 522 plus 11 over 2 squared, which is 11 times 11 is 121. 2 times 2 is 4. Okay, now I can factor the perfect square trinomial on the left. That just becomes x plus 11 over 2 squared is equal to this 522 plus 121 over 4. 522 times 4 is 2088. So 2088 over 4, okay, plus 121 over 4, okay? Now, take the square root of both sides. X plus 11 over 2 is equal to 2088 plus 121 is 2209 over 4. So it's equal to the square root of that plus or minus, of course. Okay, now I need to subtract, okay, and actually, before I subtract, recognize that I have 2,209 over 4, so that's equal to the square root of 2,209 over 2, right? Because it's the square root of the numerator over the square root of the denominator, okay? Square root of 2,209, that's actually a perfect square, okay? So that is 47. So now I have x plus 11 over 2 is equal to 47 over 4. Subtract 11 over 2 to cancel that out. And x is equal to, sorry, that's plus or minus, okay? X is equal to negative 11 plus or minus 47 over 2. Okay? Oh, and this should have been 2 right here. Sorry. 2, 2, 2, because the square root of 4 is 2. Okay? So x is equal to negative 11 plus or minus 47 over 2. Okay? Now, negative 11 minus 47 is going to give me a negative value for x. That can't happen because we're talking about distance. So I can knock out this negative, okay, and do negative 11 plus 47. Negative 11 plus 47 is 36 over 2, so x is equal to 18. So the original dimensions of the garden were 18 feet by 18 feet. And that is completing the square.